Wouldn't we all love to go underground to avoid the traffic jams? And when Elon Musk talks or tweets, people take notice. Over the weekend, the billionaire businessman known for pushing the boundaries of travel was at it again, tweeting about his latest plans for the Hyperloop.
Welcome to Moonshot. I'm Christopher Lawson, and for most people, travel can take up a fair chunk of your day. I know for me, I can sometimes spend more than an hour getting home from work in all that peak hour traffic. So how would you feel if you never had to deal with all that slow traffic ever again?
Is that an Elon Musk idea? So it is a train in a vacuum loop. And because there's no wind resistance and all of that sort of stuff, it can go very, very quick and can travel long distances in a very short amount of time.
I can't see the point of it myself.
Why?
Because I think the cost of investment exceeds the benefit that you'd get by travelling that fast.
So you don't think there would be any benefits?
I don't think it would be cost efficient.
I think it's interesting. I don't know if I would want to be in a tube for 30 minutes.
Why not?
It's a bit boring, isn't it? What are you going to do for 30 minutes in a tube?
How do you think it would change your life though? Would you use it?
I guess so. It's probably easier. Less congestion, imagine. Probably simpler. I'd use it. Yeah.
Now, in case you haven't already guessed, on today's episode, we're going to explore the idea of Hyperloop and the potential it has to completely revolutionise the way we get around. But before we take off down this Elon Musk rabbit hole, it's time for a word from our sponsors.
Is it a train? A plane?
No.
An automobile?
It's
Transporter machine?
It's a cross between a Concorde and a railgun.
That's billionaire ideas man Elon Musk, the guy behind Tesla and SpaceX, talking about his idea for the Hyperloop back in 2013 at the All Things D conference.
A Concorde and a railgun, okay.
Yeah.
But you're not, you don't,
I'll throw something else in there just to make it sound even more bizarre. It's a cross between a Concorde, a railgun, and an air hockey table.
But
if they did a three-way and had a baby somehow.
You wouldn't want to go a little bit beyond that? Or?
Oh my God.
Okay.
Let's go.
Let's go.
Elon had decided that the California high-speed rail system development was a bit lackluster, saying it has the dubious distinction of being the slowest bullet train and the most expensive per mile. Elon's dislike for the California high-speed rail system led him to dream up an idea for a new form of transport, something that he called the Hyperloop. Unlike other forms of transport, Hyperloop would be immune to weather, never crash, and would go 3 or 4 times faster than a bullet train, reaching potential speeds of more than 700 miles per hour, all powered by electricity, as Elon detailed for Pando Daily prior to releasing the idea.
And it would cost you much less than an air ticket or cart, much less than any other mode of transport, because the fundamental energy cost is so much lower. And I think we could actually make it self-powering if you put solar panels on it.
Now, you might be asking yourself, what exactly is a Hyperloop? In 2013, Elon released a 57-page alpha document detailing his definition of the concept. He wrote that Hyperloop consists of a low-pressure tube with capsules that are transported at both low and high speeds throughout the length of the tube. The capsules are supported on a cushion of air, featuring pressurized air and aerodynamic lift. So similar to a puck gliding across an air hockey table, the capsule or pod would travel through this low-pressure tube, floating on a cushion of air, allowing the pod to move at high speeds safely. For propulsion, magnetic accelerators would be planted along the length of the tube, propelling the pods forward. And the low-pressure tube design is important, because as Elon pointed out, when you're talking about a system that could stretch over hundreds of miles, it becomes incredibly difficult to maintain a vacuum, but you can maintain a low-pressure system. Each pod would hold a small group of people similar to the size of a bus and head to only one location. And it would be similar to catching, say, the tube in London, where you just turn up and jump on. And if you miss your desired Hyperloop, there will be another one just leaving in a minute.
What really intended to do with the Hyperloop was really to spur interest in new forms of transportation. And I think, I'm starting to think this is really going to happen.
While Elon Musk assembled this idea for the Hyperloop, the basis of the concept has been around for more than 100 years. In the early 1900s, Robert H. Goddard, an American engineer, developed a concept for what transport might look like in the 1950s. He proposed an idea of having trains that would run through tubes under a vacuum and be suspended in the tubes using electromagnets. The trains would only be limited in speed by the force exerted on the passengers, with many suggesting it could potentially travel much faster than the speed of sound. The concept came to be known as vac train, and the idea of using electromagnets is what we would now call magnetic levitation, or maglev, which has been used on many fast train systems around the world. More recently, in the late 1990s, Switzerland started looking to implement a commercial system based on vac train technology. Called the Swiss Metro, the project involved building an underground metro system that would operate in a vacuum, allowing passengers to travel quickly between cities. As an example, it was planned to reduce a trip from Zurich to Bern from around 1 hour down to just 12 minutes. However, in 2009, after spending more than $10 million, the project was abandoned due to a lack of political support. Hyperloop, however, is different from VacTrain in that the concept used an air cushion instead of maglev technology, and also that you aren't looking for a complete vacuum, just a low-pressure environment, which Elon said would be significantly cheaper to operate. The other unusual thing that Elon did with Hyperloop is that he released all of the ideas publicly and open-sourced it, letting the market put his idea into practice because he simply didn't have the time and resources to work on it. And since then, his company SpaceX has been supporting the idea, holding various competitions to encourage engineers and students to develop prototype pods that might one day be used in production.
What this competition is about is encouraging people to think about new modes of transport, things that could radically transform cities and the way people get around. And what you're working on is the only thing I'm aware of that could actually be a radical improvement of this current state of the art.
The Hyperloop pod competition started in 2015. In 2018, 20 student teams from over 40 countries were accepted to showcase their pods. For the competition, all pods must be self-propelled, and teams are judged on one criteria: speed. Only 3 teams made it to the final competition, and the winner was a pod that reached the maximum verified speed.
The one great thing of the Hyperloop project and the Hyperloop competition is that there are two main factors, I think, regarding the Hyperloop in particular, is that on the one side, it's something that nobody has ever built. Like, nobody knows exactly how to do it. There is a white paper from Elon Musk, but that's also just a concept. That there is no detailed information on how you would build stuff.
That's Gabriel Semino, one of the members of the German VAR Hyperloop team from the Technical University of Munich, who have won the competition for the past 3 years.
It's not like building a car where you kind of know how a car is designed and it has 4 wheels and so on. It's very, very free design process. That's one of the things which are really great about working on the Hyperloop competition. The other thing is just you know what you're trying to do and what you're contributing to is trying to have a new transportation system.
In the first year of the competition, the overall design of the pods was important. However, now the SpaceX competition has a specific focus on how fast you can go within the length of the test track, meaning all the teams are optimizing their designs to figure out how you might reach the fast speeds that have been promised. In 2018, the VAR team reached a top speed of 284 miles per hour, or 457 kilometers per hour. The competition was held at the SpaceX test track, which is a 1-mile Hyperloop track in Hawthorne, California. This smashed a previous Hyperloop speed record set in December 2017 by Virgin Hyperloop One, who had reached 240 miles per hour.
The factor which is the most important for for reaching high speeds and having an acceleration is what we call power density. And that means how much energy per time, which is power, you can transfer to the rail and divide it by the amount of weight you have. Obviously, if you have a higher power, you can accelerate faster. And if you have less weight, the energy you have transfers in higher speed. And from the second year to the third year, we actually improved the power density by a factor of 5, which actually is a considerable improvement in power density. And so we're actually confident that the third pod could actually travel even faster than what we actually managed to make him do at the third competition. So that's why we're looking forward to the fourth competition to actually even improve on the speed we had this year.
In 2018, the team went with a design that was 50% faster than the previous year. They kept the weight for the pod down, which allowed them to go much quicker by being strategic about what materials they used.
What we are doing right now is prototypes, in particular prototypes that are going at a very high speed. And since we're not building pods in series, but we have just F1, we kind of choose the best materials we find, and don't focus that much maybe on the scalability of the design when you have to build thousands pods like this. And probably also it's not surely optimized for price since it's a one-off thing.
While having a small-scale competition is all well and good, there still hasn't been a full-sized Hyperloop system that people can actually travel on. But there are plenty of companies trying to be the first. In China, there are already plans to build a small commercial line in Guizhou.
Let me just first ask you about the China project. Why Guizhou?
Well, actually, Guizhou is a very interesting area. It's a touristy area. It's actually not a test track, it's a commercial line. So we're just going to start out with the first 10 kilometers and later extend it. The first 10 kilometers are just being used to do all the certification and regulation. So we will actually have revenues there. You know, there's a lot of tourists going to Guizhou, specifically to Tongren. It's one of the most touristy areas.
That's Dirk Alborn, CEO of Hyperloop Transportation Technologies, speaking with CNBC in July 2018. Hyperloop Transportation Technologies is just one of several companies taking on the project and trying to make it a reality. Another company that is leading the charge is the Canada-based Transpod.
So on top of being innovative and different, wanted to make sure that from a cost point of view, it's appealing. And that's the main difference compared to our competitors, to make sure. And then the IP being developed so far, we receive really great feedback from Canada, from industrial players, and that's the main reason why today we start to get more and more traction. I'm Sébastien Gendron. I'm the CEO of Transpod, a Canadian-based company in Toronto, designing and building a future Hyperloop system.
Founded in 2015, Transpod's goal with Hyperloop is to create aerospace-like vehicles that use magnetic levitation or maglev propulsion.
And the main difference compared to a train is that as we're dealing with smaller vehicles, but with higher frequencies, really to provide the end user the frequency of the subway with the speed of the aircraft. Like today, when you go to the railway station or to the airport, you don't have the choice to take that train, or you need to go or to arrive at the airport at a certain amount of time or at a certain time. And if you miss the time slot, you need to pay to repay a flight ticket. Tomorrow, with such a system, the idea is same as for subway. You get a ticket, but even if you miss it, you know that you will have the next available pod you can board to reach your destination. So that's really the intent behind it.
What is that process like for someone?
Yeah, the process is it's quite similar to what we have, even if we're working to improve the boarding process. Like today, there is more likely it's going to be a ticketless process where you can book your ticket on your phone, and I mean, we start to see that on I would say the latest phones where you have NFC tags, where you just pass on some kind of, I would say, not a portal, but a gate, where it scan or debit automatically your bank account and saying, okay, you've passed the gate and we just debited your flight ticket or your transport ticket automatically, and you won't have to present anything.
Transport is still in a relatively early development phase and are currently working on the technology to make their system happen. Although they're also working on locking in routes for their Hyperloop system, they've just received a construction permit to build a 3-kilometre test track in France about 300 kilometres south of Paris. They'll use the test track to validate their ideas, and they're also planning a second test track of 10 kilometres in Canada. And they're working on full-scale routes around the world, such as between Calgary and Edmonton in Canada, Melbourne to Sydney in Australia, Paris to Toulouse in France, and they're also planning a route in the Middle East. How much would it cost to build a fully functioning system?
So today, to develop the technology, we're raising, the objective is to raise around between $200 to $300 million. So that's typically the same amount. That's the equivalent of what companies such as Alstom or Bombardier or Siemens will need to develop a new train. So that's for the tech part of it. And for the infrastructure today, we're around between $20 to $30 million per kilometer. So within the same range as what we need for an high-speed train, but with a better value proposition. And why better is that as you're dealing with smaller vehicles, you can mix with freight. So you can have the line used, for example, for 100% for passengers during peak hours in the morning and in the evening. And then during the day, you can mix it with freight vehicles.
Transport is making good progress in the quest to build a Hyperloop system, but they have plenty of competition, and we'll have more on this high-speed idea right after this break. Welcome back to Moonshot. I'm Christopher Lawson, and before the break, we were diving deep into the implementation of Hyperloop, the much talked about brainchild of everyone's favourite moonshot thinker, Elon Musk. And one of the companies we were looking at was Transpod. But when it comes to Hyperloop, there's still one company that has been lapping up media attention everywhere, and that is Virgin's Hyperloop One.
The operation of the system is pretty different from a train or a similar sounding system out there. So with these pods holding 15 to 30 people, you can load them very quickly, and the pods are very on demand. So you're not scheduling your Hyperloop journey days, weeks, months ahead of time. You're deciding now that you want to go to the neighboring city. You're maybe getting on an app and calling your Hyperloop journey and going to the station and getting on the pods. These pods can be sent multiple times a minute. And they don't go and stop at every location to let people off. Your pod is just going to your final destination. So when you pull all this together, you have this autonomous control system that's controlling the entire thing. It's really a very fundamentally different form of travel from what we have now.
This is Kristen Hammer, who manages the materials engineering team at Virgin Hyperloop One. Kristen previously worked at SpaceX before heading to another company, and some of her former SpaceX colleagues started moving across to this new upstart called Hyperloop One. Hyperloop One first started in 2014, and in 2016 set about building a full-scale test track called DevLoop.
So I had been doing welding engineering positions actually even here, and I ended up here because they were looking at this big DevLoop test track project, which is a big metal tube. And they said, gee, we have to weld this. We should probably get someone in here who knows how to do that.
The DevLoop test track was completed in May of 2017 and allowed the team at Hyperloop One to start testing their system at full scale, making them the only Hyperloop company to have a full-scale test track.
This pod is propelled down through the tube with a linear electric motor. So similar technology that is in a standard motor, but if you unroll that to the length of the tube, then you have the linear electric motor, and then it's levitated with a form of magnetic levitation. So we've removed the friction from air, or most of it. We've removed friction from wheels. And this is really what allows us to go very quickly.
So if you read Elon's white paper, that actually ran on air bearings.
This is Ryan Kelly, Head of Global Marketing and Communications at Virgin Hyperloop One. Both Ryan and Kristen say the Virgin team's current Hyperloop designs are a far departure from the original Hyperloop concept.
And we tested that. In theory, it was interesting, but in real life, it didn't work, which is why we moved to magnetic levitation.
When I came here, there were around 50 people, most of those being engineers. At that point, we had already moved on past the air bearing solution. So we move at a really aggressive pace, and still take the time to learn everything. So we really exhausted all the testing possibilities on DevLoop to learn as much as we could. There's maybe a handful of things we could still work on, but we said, okay, well, what's a better way that we can learn quickly? And it's in more testing. So it's really been pretty cool as an engineer to watch this whole thing kind of go at the speed that it does, and how much we've learned about the right way to build this system and what works and what doesn't through all of this testing.
Hyperloop One has received almost $200 million in venture funding, making it the most funded Hyperloop system. And a large amount of that funding has come from Virgin, which is why in October 2017 they became Virgin Hyperloop One. And from December of 2017 until October of 2018, Richard Branson himself joined the board as chairman.
How do you see your MOU that you have signed with the state of Maharashtra?
We're very excited that it's been signed, and I think that when you see the amount of traffic on Indian roads, I think people in India are going to be very excited to be able to travel in this way.
Realistic time frame that you're looking at?
Realistically, before it's finished, will be about 6.5, 7 years.
The Virgin team has been working with the state and federal government in India and looking at the socio-economic case for building a Hyperloop there. And they already have a signed intention to build for a Hyperloop route from Mumbai to Pune.
The Mumbai to Pune route is the reason why I get up in the morning to work at Hyperloop. There are 110,000 cars on the road every single day between Mumbai and Pune. It's about 95 miles between the two cities. Right now, it takes about 3.5 to 4 hours to drive or take a train, and we can do that in 22 minutes. And so the impact of that is creating about, I believe, over 900,000 jobs over the next 50 years. And more than 55 billion in socioeconomic benefits to that region alone, taking out 150,000 tons of pollution out of the air. So it's solving a lot of problems that the governments are at the federal and the state level are thinking about every day.
The Virgin team are also looking at other routes, including something in the Middle East and other locations like Europe and the United States.
So we need to look at the route, but we also need to look at the government and how excited they are for this opportunity and hungry to do this with us. Because we don't need to boil the ocean. We need a couple of projects in the beginning. And once that first project goes live, and we show that it's safe and we show that it creates these socioeconomic benefits, and that it's not a loss leader from an investment standpoint, we think that there are going to be Hyperloops all over the world.
The company is also building a research and development facility in Spain to help them with testing components of their vehicles, and also to serve as a gateway into the European market, which is already pretty familiar with high-speed travel systems. It's not very often that a new form of transport is invented. Sure, we see new types of cars and planes and trains all the time, but a completely new transport system is rarely ever developed. However, when we're talking about building a system that runs through all these low-pressure tubes that will be built over hundreds and hundreds of kilometres, what kind of impact might a working Hyperloop system have on our environment compared to a more traditional transport option?
If we aren't more sustainable, then we've done something very wrong. We have the opportunity here with a clean slate to figure out what society needs now, and one of those things is a sustainable mass transportation system. So we have the runway to do that, We are an energy agnostic system. We want to take a step back because there are two sustainability issues. One is the building of the linear infrastructure, which can create a large carbon footprint. The other is actually operating the Hyperloop system. We feel very confident even at this point that over time, the energy that we're using to operate the system will be much less than high-speed rail. We're also looking at creating a linear infrastructure and maintaining one that's cradle to cradle versus cradle to grave.
What do you mean by that?
Yeah, so let's say that we need to do maintenance on the tube, that when a part is worn out, we just don't throw it away and scrap it. How do we take that part and recycle it, reuse it, and then bring it back into the system, not only at a quality that is and safety standard that is like it being brand new. And to that point, when you do something like that and you're looking at it from a cradle to cradle standpoint, not only is it more sustainable and our footprint is much lower, but it's also more cost effective and efficient.
Being in that low friction environment allows us to use less energy. So if you look at comparing us to maglev needs the power constantly to fight through the air. So just overcoming air resistance. And any system operated out in air has this problem. Because we are in this vacuum environment, this low pressure environment, it takes a lot longer time or distance, look at it either way, before we really are affected by that air pushing back on us, and we need more power to push past it. So the idea of us kind of powering up, getting up to speed, coasting until we get to some slowed down speed at some distance down the route, and then doing another boost of power and coasting and boosting power is really very feasible.
I know what you're thinking. What about the price? All of this talk about building futuristic Hyperloop technology might sound really great, but unless it's at an affordable price to you, the consumer, will anybody actually use it?
We're talking about mass transportation systems. So what I can say is if we don't set a price where the general public can't benefit from that, then we're not going to be in business. We have to be able to balance that supply and demand. This isn't, something for the elites. It is going to be way less than a plane ticket, but at airline speeds.
So when will we all be walking down to our local Hyperloop station and stepping onto a Hyperloop to get to our destination? Ryan says it all kind of depends on governments and regulation, because as we all know, governments aren't usually known for moving at high speed to implement new technology.
We want years, not decades. We want to see a Hyperloop system up and running by the mid-2020s in a region around the world. And that's not to say that, safety is our number one priority here, and regulating a completely new form of transportation is not easy. And we are working around the clock to do it. But governments, and this is just a fact, if you look at private companies, if you look at governments are slow movers sometimes. And even if you look at infrastructure in the United States, we haven't adopted high-speed rail because, if you look at where high-speed rail has tried to be created, the socioeconomic case isn't there. And obviously we've piqued interest in the United States and all over the world, that the economic case is different and it's there, and there's a need and there's a demand for what we're offering. And governments are moving at lightning speed compared to how they usually move.
Is that realistic? I mean, you just mentioned like the government issues, but do you think it's realistic by mid-2020s?
I think so. I really do. We're already I think the thing about Hyperloop that's a little bit different than something like an Uber or a Lyft or scooters, etc., is that we can't just plop into your neighborhood. We have to work with governments, and we need to work from a local, state, federal level And we also need to work with communities. So our goal isn't just to plop down there, as a foreign entity and just build and then beg for forgiveness later.
Hyperloop may have started as this dream in the brain of Elon Musk. But whatever way you look at it, there's an industry developing around this technology. One day you might be walking down to your local Hyperloop station to head to work in a city that might be hundreds of kilometres from where you live. And it's this evolution of the idea from just something in Elon's brain to a practical, real project that Kristen says is one of the misconceptions about Hyperloop technology.
What's hard is explaining to people that there is more than one Hyperloop company and that it's not just Elon with this idea. It's actually that a Hyperloop is a noun and not just a company. So that's the biggest one for me that I find myself constantly explaining to people. And every time I explain it, then I get all of this, oh, wow, I never knew.
You're kind of like going through this transition period where you take this amazing technology and then you actually do something practical with it.
Yeah, we're leaving the science fair. How do we make this, something that's real and out there for the public? And that's a huge challenge that we're extremely excited about. We're getting close, and I just can't wait to break ground on our first system.
This episode of Moonshot was hosted by me, Christopher Lawson, with research by Mahalia Carter. Additional production and scripting by Jasmine Mee Lee. Our theme music is by Breakmaster Cylinder, and our cover artwork is by Andrew Millist. Remember, you can always catch up on previous episodes of the show by subscribing in your favourite podcasting app, or head over to our website, moonshot.audio. Join us next time as we keep exploring the future on Moonshot.